This subnetting, subnet, and subnet mask, these are all different concepts, right? Subnetting, subnet, and subnet masks are different concepts. This subnetting process creates subnet. So it creates what? Subnetting is a process that creates subnets, and subnets are identified by subnet mask. So we can only identify a subnet if we have the subnet mask, right? Then we know how to calculate a subnet mask, where we will turn all the bits representing the network portion 1 and all the host portion bits will turn 0, right? So subnetting creates subnets, and subnets are identified by subnet masks. Subnets are identified by subnet mask, right? So subnetting is the process of dividing a network and its IP addresses into segments, each of which is called a subnetwork, or in short, we can call it subnet. So we can do subnetting process by borrowing bits from the host portion. So let's have a look at the number that how many number of bits we can borrow from the host portion in a specific class. For example, uh, if I talk about class A, how many number of bits are there in the host portion? Yes, we have 3 octets for the host portion, means we have 24 bits in the host portion. So how many number of bits we can borrow? At max, we can borrow 22 bits. And the minimum number of bits that we can borrow are 2. So if for the subnetting process, if you want to borrow the minimum bits that you have to borrow are 2. And what is the maximum number? For example, in host A, we have 24 bits. We have to leave 2 bits for the network and broadcast address. So we just cannot borrow all of these 24 bits, right? So the maximum number of bits that we can borrow for the subnetting process are 22. Similarly, in class B, we know that 2 octets are there for the host portion. So this means 16 bits, and we have to spare 2 bits. This means we can borrow 14 bits to create subnet, or for the subnetting process. Similarly, in class C, this is the smallest block. Obviously, here we have first 3 octets for the network portion and 1 octet for the host portion, means 8 bits, and we have to spare 2. So this means the maximum number of bits that we can borrow for the host portion are the maximum number of bits that we can borrow for subnetting process are 6. So this is the number that this is the maximum number of bits that we can borrow in a class for the sake of subnetting process, right? And let's try to understand the borrowing of the bits and creating subnets and see how we calculated using this table of class A, right? So for example, look at the first column. Here we have the subnet mask, and what is this subnet mask in the first row? Yes, you're right. This is the default subnet mask. So this is what? This is the default value. Why this is the default value? Yes, we know, because in default arrangement, the first of class A, the first octet represents the network part, and the remaining octets represents the host portion, right? So this is the default arrangement where we have turned all the network portion bits 1 and all the host portion bits 0. So this will give me what? The default subnet mask, of 255.0.0.0. And how many number of bits are being used for masking? I mean, how many number of bits are 1? So obviously, 8 bits are 1, which are representing the network portion, right? And how many number of subnets we are creating? None. Why? Because we have not borrowed any bits from the host portion, right? So how many number of host per subnets we can create? So 2 raised to power the number of bits in the host portion. So 2 raised to power. How many number of bits are in the host portion? Yes, you're right. 3 octets, 24 bits. So 2 raised to power 24 minus 2. So this number is 16.7 million machine. We can assign addresses to 16.7 million machines. And now look at the second case here. What is happening here? So this is by default. I cannot change it, right? So the first octet represents the network part as per the standard. I cannot change it. So this value has to be 1. So what I have done here is, what do you think? What I have done here in the second octet? How many number of bits are borrowed? So we know that in this class A, the case will always be the same for the first octet. Means all the bits are 1. Means this value will always be 255. So what I'm doing in the second case here, so what I've done is I've turned on, I've borrowed 2 bits. So I will always borrow bits from the left side. So this is not the case that we'll borrow the bits of our choice. No, we'll always borrow bits from the left side. So I have borrowed 2 bits, right? And all the other bits are 0 for the calculation of the subnet mask. Okay, so what is the value of these 2 bits? We know that the value of this leftmost bit is 2 raised to power 7, means 128. And what is the value of this bit? 2 raised to power 6. Yes, 64. This means what is the value of this octet? 192. 128 plus 64 is 192. And yes, we know that these portions are representing host portion. All bits are 0. So this means dot 0 dot 0. So what's the next subnet mask? 255.192.0.0. Now, how many number of bits are used for masking? So 8 is by default, the first octet representing the network portion. So what we have done now, we have borrowed 2 more bits, right, from here. Okay, so this means now the number of bits that are being used to represent the network portion are 10, right? Because now these 2 bits of the host portion become a part of the network, as it will be representing the subnet address. So how many number of subnets I can create? So this formula is very simple. So I'll 2 raised to power the number of bits borrowed. How many bits are borrowed here? 2 minus 2. So this value is 2. So I have created 2 subnets by borrowing 2 bits. And how many number of machines can be assigned IP addresses within each subnet? This depends how many bits are left in the host portion. So previously, the total bits in the host portion were 24. So since 2 bits have become part of the network, so the remaining bits are 22. So how many number of host addresses I can have? So 2 raised to power 22 minus 2. So this will give me this number, okay, which is 4.1 million machines. And similarly, here, what I've done is I have borrowed another 2 bits. So now, in this case, I have borrowed the bit number 32 and the bit number 16 also, right? So this bit is also 1, this bit is also 1, right? And now the value would be 240, right? So 255.240.0.0. So how many number of bits are borrowed now? 1, 2, 3, 4, right? So 8 bits were already there by default. So 8 plus 4, we have 12 bits for masking now, right? So how many number of subnets we can create again? How many number of bits are borrowed in this case? So 2 raised to power 4 bits are borrowed minus 2. We can have 14 subnets, right? And how many number of machines will be there against each subnet? So whatever the bits are there, remaining bits are there, we can calculate. So how this will be calculated? So 2 raised to power, how many bits are there, by the way, in the host portion? Since 4 bits have been borrowed, so the remaining bits are 20. So 2 raised to power 20 minus 2. So this will give me this number. So 1.404 million machines can be assigned IP address. So similarly, what is happening here? What do you think? What has happened here? So we have borrowed the complete octet here, the second octet. All the bits are 1. Means I'm using all this complete octet for creating the subnet address 255.255.0.0. Right? How many bits are used for masking? Yes, I have 8 bits here and again 8 bits here. So this means 16 bits are representing the masking process. And how many bits are there for the host portion? 2 octets, 8. So 2 raised to power Um, uh, so 8 here and 8 here. So 2 raised to power 16 minus 2. So we'll have this much number of uh, nodes, this much number of nodes here uh, against the each subnet. And how many number of subnets we can create? Obviously, how many number of bits are borrowed? 8. So 2 raised to power 8 minus 2 is 256. Right. So this is similarly you can understand the rest of the table, that how the subnet mask will be calculated as we'll keep borrowing bits from the host portion to create a subnet. Okay. Similarly, this is a different representation for class B to give you a better understanding of the position of the bits. Again, the first field here is representing what? Is representing the default subnet mask. Why? Because we know that in class B, the first 2 octets are representing the network part, and remaining 2 octets are representing the host portion. So we know that in class B, the first 2 octets represents the network part, and remaining 2 octets represent the host portion. And if all the bits are 1 here, so this value will be 255, right? And again, since this is the network portion, and we know that if we want to calculate the subnet mask, we turn all the bits 1 in the network portion and all the bits 0 in the host portion. So it's again the value is 255 dot 0 dot 0, right? So this is the default subnet mask. So we can also look at the position of the bits in the octet. So you can see that all the bits are 1 in the first 2 octets. Why? Because these octets represents the network part, and all the bits in the host portions are 0, right? To calculate the subnet mask, and this is the default arrangement, right? And how many number of subnets are created? None. Why? Because we have not borrowed any bits from the host portion. Then how many number of machines can be assigned against one IP address? So for that, again, we'll see how many number of bits are there in the host portion, 16. So 2 raised to power 16 minus 2, we know this number is 65,534. Now what we have done here is that we have borrowed 2 bits from the third octet, the host portion, right? So we know that this address is by default 255.255. Now dot, how many number of bits are borrowed? 2. These 2 bits of the host portion are borrowed for subnetting process. And what are the values of these 2 bits? Yes, the value of this bit is 190, 128, and the value of this bit is 64. So this means now the subnet mask would be 255.255.192.0. And how many bits are borrowed? 2. So how many subnets can be created? So again, 2 raised to power the number of bits borrowed, 2 minus 2, I'll be able to create 2 subnets. Okay. And how many machines will be there against each subnet? That again depends how many bits are there in the host portion. So since 2 bits have been borrowed, so the remaining bits are 14. So 2 raised to power 14 minus 2 is this number, 16,382. And similarly, we can look at the rest of the table, that how we'll be having a subnet mask depending upon the number of bits that are being borrowed. Similarly, in class C, this is the default arrangement, since we know that in class C, the first 3 octets represents the network portion. So these octets represents the network portion, and the last octet represents the host portion. So these are the network portions. So if I have to calculate subnet mask, what I'll do? Yes, as a first step, I'll turn all the bits in the network part 1, right? And all the bits in the host portion 0. So what will the value? Yes, we know that its value is 255.255.255.0, right? So this is the default arrangement, right? This is the default subnet mask of class C. How many number of bits are 1 or for use for masking? 14, 3 octets, 1, 2, 3, right? 14 bits. How many number of subnets are created? None. Why? Because we have not borrowed any bits from the host portion. And how many number of bits, how many number of nodes will be there against each IP address of class C? The number of bits in the host portion 8, so 2 raised to power 8 minus 2, Yes, right. It's 254. And again, this is the binary arrangement of this default subnet mask. So you can clearly see that these octets are representing the network part, all the bits are 1, and this octet is representing host portion, all the bits are 0. And what has happened here in this case? So what I've done is I have borrowed these 2 bits from the host portion, and now its value to calculate subnet mask, its value will also be 1, right? So I'll turn these 2 bits 1 also, right? So what will be the subnet mask now? So again, you can see it from here that from this host portion, these 2 bits are 1 means these 2 bits are representing the network part now, is a part of the network portion now, right? So what is the value of these 2 bits? Yes, you're right. The value of this bit is 2 raised to power 7 is 128, and the value of this bit is 2 raised to power 6 is 64. So now my subnet mask would be 255. This is by default dot 255 dot 192. How many number of bits are borrowed? 2 raised to power 2 minus 2 is 2, so we'll be creating 2 subnets. And similarly, we can look at the rest of the table, that how we will be able to calculate a subnet mask by keep on borrowing bits from the host portion.